Hello everyone, welcome back again. This is the third part of the regression analysis. So as I explained, one of the assumptions is to ensure that the residuals should be normally distributed. And how do we check the normality of anything? Like I explained, you can check more details in my normality video. But before we move on, let me just explain. For it to be normally distributed, the tail to the left hand side should be equal to the tail or approximately equal to the tail to the right hand side, and most of the information should lie inside this particular region. And then we also have the bell shape, so you could see that it is normally distributed. So that means this assumption is being satisfied, and that means the data is satisfied for regression analysis. So let's see how we report it. This is the title: a histogram of standardized residuals for the regression model predicting monthly revenue. A histogram of standardized residuals was examined to assess the normality assumption of the regression model predicting monthly revenue. The distribution of the residuals approximated a normal distribution as indicated by the bell-shaped pattern of the histogram and a close alignment with the superimposed normal curve. The standardized residuals were centered around 0, that's mean is approximately 0, with standard deviation closer to 1, that is 0.981, which is consistent with expectations for standardized residuals. Additionally, the majority of residual values fell within the acceptable range of -3 to +3, that is within this range. So majority of them fall within here to here. So that is the acceptable range, suggesting the absence of outliers. Overall, the visual inspection of the histogram indicated that the assumption of normality of residual was reasonably satisfied for regression model. So this assumption must be satisfied before we even report our regression analysis. So when you run the analysis, you have to bring this one first before you go in. That will tell that you have assessed the assumptions of normality for the residuals. So now let's move to this one. Now this is the regression model. You give it a title: multiple linear regression analysis predicting monthly revenue from restaurant operational factors, and the sample size is 270. So when you take it, like I explained earlier, we have to put the table in a nice way. So we have our predictors. These are the predictors, and then we report this particular column, the beta unstandardized. We don't report this one. This one is just the relative importance. And then this particular side, the p-value here is also very important. And then this one, the tolerance and the VIF. So when you check, you realize that some of them, so you just report indicating, because the predictors are many, you report indicating those that are significant and those that are not significant. Then you also check the VIF if most of them are fall within the multicollinearity. So you could see that with the tolerance, none of the tolerance value is less than 0.1, which means there is absence of serious multicollinearity. And the same apply to the VIF. None of them is greater than 10. That means there is absence of serious multicollinearity. Now with the ANOVA and then the model summary, the information we need from them are very few. For that matter, we don't have to give a table for them. So we just took those information and put them under here. In the model summary, we have our R square and then the adjusted R square. And then with the ANOVA, we pick the p-value and then the f. So, but we always play much emphasis on the p-value here by comparing it with the threshold 0.05. Here I just defined the b. Here is the the unstandardized coefficient. SE is the standard error, and then B here is the standardized coefficient. VIF is variance inflation factor. So anything that we have shortened here or which is not very clear, then we just make it clearly here. So now this is our report. The results of the multiple linear regression analysis are presented in table 1. So that's the name of the table. The regression model was statistically significant. That is, we use the ANOVA results. So that is the overall, indicating that the set of predictors jointly examine a significant portion of the variance explained in monthly revenue. The model produced a strong correlation between observed and predicted values. That is from the model summary. So we have it here. The coefficient of determination, that is the R square, showed that 74.1% of the variance in monthly revenue was explained by the predictors. So that is the R square value. After adjusting for the number of predictors in the model, the adjusted R square was this, indicating that the model maintained a high explanatory power even after accounting for model complexity. So this one, after adjusting irrelevant things from the R square, the model still explains high power. So now we move to the other section. So here we now want to tell the influence of each of the predictors. So we pick those that are significant first, and then we move to those that are not significant. So we come here. Examination of the regression coefficient revealed that several predictors significantly influence monthly revenue. So we have their influences here, specifically location store. This is its influence with the p-value. Service quality has an influence of 1024.44 with p-value 0.001. Food quality 1632.51. That means if food quality is increased by 1, then monthly its influence in the monthly revenue will also increase by this. So since they are many, we just follow that order. You can pause the video and then check how I report them here. So up to customer footfall were significantly positive predictors of monthly revenue. This indicates that increases in these variables are associated with higher levels of restaurant revenue. So each and every one of them has high influence on the monthly revenue. In contrast, these ones are not significant. Customer satisfaction with p-value this, and then online rating with p-value this, because all the p-values here are greater than 0.05, were not statistically significant predictors of monthly revenue when other variables were controlled for in the model. So because they are not significant, we don't even need to bring their effects, because those effects are not significant. We only bring the effect of those that are significant. So mostly that is how we report it. Then we come to the multicollinearity. That is by using the VIF and the tolerance. So multicollinearity diagnosis further indicated that tolerance values ranges from 0.188 to 0.983, while variance inflation factor values ranges from 1.02 to 5.32. Since these values fall within the acceptable threshold, there was no evidence of severe multicollinearity among the predictors. So basically, this is how we report regression analysis. You start with checking the assumption, then you come in to check the coefficient that has much impact or significant influence. Then you check with their multicollinearity, and then in that case you have your standard report for regression. Please, if you like this video, you subscribe and then turn on your notifications so that you will not miss further important videos. And then I will leave the data set so that you can download and practice. Have a good time. Bye.